Hi, folks. Welcome to this example. We're going to take a look at question number 4 from the My Open Math Chapter 7 assignment on uniform distribution. Okay, so the number of seconds x after the minute that class ends is uniformly distributed between 0 and 60. And so if we think about this word uniform distribution, all right, this we can always go back to chapter 5 if we have any questions about uniform distribution. Okay. But one of the things that was important about uniform distribution is that we have sort of a starting point and an ending point. And so this 0 is our starting point, we call that A, and our 60 is our ending point, or we call that B. And so when we look at question A, it says, what is the distribution of this number of seconds? And so what we put into our uniform distribution, we put our A and our B. Like, in other words, what's the range that we're looking at? And so we are going to type in 0 to 60. Okay. All right. Now, suppose that 39 classes are clocked. What is the distribution of X bar for this group of classes? And so when we look at our distribution of X bar, we're going to find, we need to know our mean and our standard deviation. Okay. But this is for the sample of 39 classes, not for like all of the classes in the entire population. Okay. So we go back to chapter 5 and we find that our mean equation, or that letter mu, is equal to a plus b over 2, which in our case is 0 plus 60 divided by 2, or 30. Okay, so our mu is 30. But to find our standard deviation, all right, we want to find sigma. And the sigma equation from chapter 5 was b minus a squared over 12. And then we take the square root of that. And when we do that and type that into our calculator, we should end up with about 17.3205. Okay. And let me actually go back. We're not going to put b minus a. We're actually going to use the numbers we have. So 60 minus 0. Okay. Now, if we put 17.325 in that second spot, we're going to get it wrong. And I want to tell you why. The reason why we're getting it wrong is because this is our standard deviation for the whole population, but we're looking at the standard deviation for the mean. And so what we need to do here, just like we did in the previous video, we're going to take this value. All right, we take our sigma, we divide it by the square root of how many samples we have. And so what that means for us is we're going to do 17.3205 divided by the square root of 39. And when we do that, we get about 2.7735. Okay. That's the number that we're going to put in here. Okay. Last part. What is the probability that the average of 39 classes will end with the second hand between 24 and 29 seconds? And so let's go and use StatCrunch for that, okay? So we want to make sure we're doing the between one, but we're going to need to type in new means. So we have 30 as our mean. Our standard deviation is 2.7735, and we're looking for the probability that we end up with the second hand between 24 and make sure I type this in right, 29, and we click compute. Okay. And so when we get that, we see it's 0.34 and then 39, but the 9 is followed by a 5. So I actually have to round up. So it's going to be 345. Okay. All right, let's check our answers on my open math. So we wanted it to be between 0 and 60 for the uniform distribution, right? My mean is going to be 30, and my standard deviation is not the 17.3205, but rather it's the 2.7735. And oops, we're looking at the when will the second hand be between 22 and 26 seconds? Not a problem. We go back to StatCrunch. We want between 22 and 26 seconds, and we're going to compute. Then let me write this down. I got 0.0727. And that's what we're going to type here, right? 0.0727. Oops, 727. And let's go ahead and submit our question. Everything looks great. All right. So hopefully this helps clarify the difference between if we have it already normally distributed versus if we're looking at a uniform distribution. Okay. Now, one last thing I want to say here, the reason why we can use this central limit theorem is because we have 39 classes that we're looking at in our sample. So if we were only looking at, like, let's say 29 classes, we actually couldn't do this problem because the central limit theorem would not apply. All right. So it's okay that it's uniformly distributed, but it has to have more than 30 samples if that's the case. Okay. I hope this was helpful. Let me know if you have any questions, and I'll talk to you soon.